All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH026. This is Objective 10 in ALEKS. And I want to do a few of these examples. Most of these have to do with finding square roots and cube roots and things like that. So let me start off with an example here about finding square roots of a number. So notice this says find all the square roots of -64, and it says all real square roots. Now, let me remind you of square roots. So if we say the square root of 25, let's say, it's asking me what number times itself equals 25. So I want to know what number times itself equals 25. Well, that answer is 5. And you might recognize that a square root function is the inverse or the opposite of squaring. So because I know that 5 squared is 25, right? So I could write that 5 squared is 25. The opposite or the inverse is taking the square root of 25, and it's asking you what number squared results in this quantity under the square root symbol. So of course the answer is 5. They're asking me here, what are the square roots of -64? Well, that's asking me what number times itself equals -64. Remember, these parentheses have to be the same. Well, there can't be any answer to this, because if I take some number times itself, I'll never get a negative here. Because if these were both negative numbers, let's say I had -8 times -8, that would give me a +64. So there's no way to take a number times itself and get an answer that's a negative number. So that's why the answer here is none. Okay, so you can't take the square root of a negative number and come out with a real number answer. Okay, remember, you can read through the explanations on these to get more insight. All right, let me go to another example. Let me go here to table of a square root function. You know, by the way, if you go to the reference packet and you look at the multiplication table, you'll notice that on the diagonal are the perfect squares. So when I say perfect squares, I mean the number 25, the number 36, the number 49, and so on. These numbers are all representing a number times itself. So when I take the square root of 25, I get the answer 5. The square root of 36 is the answer 6. The square root of 49 is the answer 7, and so on. So it's convenient to look on that diagonal of that multiplication table, because it'll show you all these perfect squares. All right, it says fill in the table using this function, which is the square root of x minus 5. So let's go to the first row. It's telling me that x is 1. So really what they're asking me to do is evaluate f of 1. And all that's telling me to do is replace this letter x with the number 1. So that's going to be 1 subtract 5. But that's going to get me the result, the square root of -4. And remember, we said you're not allowed to take the square root of a negative number. So the answer here would be not a real number for this one. And when you go to do this in ALEKS, there'll be an option for you to select not a real number. All right, let's do when x is 5. So this is going to be f of 5, which is the square root of 5 minus 5, which is the square root of 0. Well, it turns out this answer is 0. So you can take the square root of 0, because remember, that's asking you what number times itself equals 0. And the answer to that is 0, because 0 times 0 equals 0. Let's go to this next one. It wants to know what is f of 9. So I'm going to replace x with 9 in this definition. Well, that's going to be the square root of 4. And I know the square root of 4 is asking me what number times itself equals 4, and that answer is 2. Let's do one more, f of 69. That's asking me to take the square root of 69 minus 5. Well, that's the square root of 64. That's asking me what number times itself equals 64. That answer is 8. All right, so in this question, just be careful. If you end up with a square root of a negative number, you've got to choose the answer choice that says not a real number. All right, let me do a few more. Let me go here. And it wants me to work out the third root and the fourth root. So let me give you a little bit of background. Remember, when we work out the square root is 25, it's asking us what number times itself equals 25. So really what we're figuring out here is because 5 times 5 equals 25, then the square root of 25 is equal to 5. But what if I put a little 3 in front like this? This is called the cube root. You see this 3 in front is the cube root. What that's asking you is what number times itself 3 times equals 27. Well, notice 3 times 3 times 3 is 27. So the cube root of 3 is asking you what number times itself 3 times equals this number underneath. So the answer here is 3. What if I took the cube root of, let's say, 64? Well, I know that 4 times 4 times 4 equals 64. So the cube root of 64 takes me back to the answer 4. Well, let's go to this example. It has the cube root of negative 27. Now, I can take the cube root of a negative number, because now what this is asking me is some number times itself 3 times has to equal negative 27, and what's in these parentheses have to all be the same. Well, I can't have a negative answer here, because a negative times a negative times a negative does get me a negative answer. So the answer to this is negative 3. Because if I take negative 3 times itself 3 times, I do get the answer negative 27. So the answer to this is negative 3. All right, let's go to part B. Part B has a negative sign in front, and then it has the fourth root of 16. So when you see this 4 in front like that, it means the fourth root. What that's asking me to figure out is some number times itself 4 times has to equal 16, and these parentheses have to all be the same. Is there some number that if you multiply it by itself 4 times gets 16? Yes, the number is 2. So the fourth root of 16 is a 2, and I bring this negative sign with me. So the answer to this is negative 2. All right, so be careful on this one. The negative sign was outside of this symbol. The negative sign was not underneath the symbol. What if the problem had been the fourth root of negative 16? Well, the answer would be not a real number. Because I can't come up with some number times itself 4 times to equal a negative result. You might say, well, why can't you use negative 2? Well, if I use negative 2 times itself 4 times, that doesn't equal negative 16. Because a negative times a negative is a positive. So these are all this is going to end up being positive 16. So there's no way to take a number and multiply it by itself 4 times and get a negative answer out of it. Okay. Let's go to another one. Let's take a look here. It says evaluating a cube root. All right, so remember, a cube root is just asking you to figure out what number times itself 3 times equals the number 8. Well, I know that 2 times 2 times 2 equals 8, so this answer is 2. Remember, I can take the cube root of a negative number, because if I take the cube root of negative 8, I know that negative 2 times negative 2 times negative 2 is negative 8. So the cube root of negative 8 is negative 2. All right, so let's go to these examples. First, they're asking us, what is f of negative 217? Well, what that means is go to the original function and replace the letter x with this number, negative 217. So this is going to be the cube root of negative 217 plus 1. So this is going to be the cube root of negative 216. So what I've got to do is figure out, is there a number that if I multiply it by itself 3 times, I get negative 216? Well, let me do some little background work here just for cube roots. So let me just do a couple of examples. I know that 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And then it turns out that 6 times 6 times 6 is 216. So this answer is going to be negative 6. Because I know if I take negative 6 times negative 6 times negative 6, I get the answer negative 216. All right, let's go to this other one. How about f of 7? Well, f of 7 is asking me to take the cube root of 7 plus 1. That's the cube root of 8. Remember, that's asking me what number times itself 3 times equals 8. And we said a little earlier that the answer to that is 2. Okay, so when it comes to cube roots, you're really being asked to find some number that if you multiply that number times itself 3 times, you get the result that's given underneath the symbol. All right, let's take a look here. All right, now on this one, this question's a little different. It's asking me to find domains. And domain is the set of allowed values. All right, now, here's something to keep in mind. If the root is an even root like this, notice this is the 4th root. When this is even out here, to find the domain, take what's underneath the symbol. We call this a radical symbol. Take what's underneath the symbol and set it to be greater than or equal to 0. The reason I'm doing that is I cannot have a negative number. Right? We did some examples to explain why when you take a square root or a 4th root, you're not allowed to have a negative number underneath the symbol. So I need to have this quantity, 2x minus 6, be positive or 0. So by saying greater than or equal to 0, that's another way to say it's going to be either positive or 0. All right, let me solve this inequality. I'm going to add 6 to both sides. That's going to give me 2x is greater than or equal to 6. Now I'll divide both sides by 2. So x is greater than or equal to 3. But they want the answer in interval notation. So let me go to a number line here. Here's 0. Here's 3. So they want me to write in interval notation this graph here. Okay. Well, the way you write this in interval notation is you write the left side and the right side. The right side is going to infinity. So I'm going to write this in interval notation as 3 comma infinity. You always put a parenthesis with the infinity. For the 3, because I'm using a greater than or equal to symbol, you use a square bracket on that. So the answer to this question is 3 comma infinity with a square bracket on the 3 and a parenthesis on the infinity. All right, let me go to this other question. It says, what is the domain for the cube root of 2x plus 4? Well, one thing to keep in mind is whenever you take a cube root, the number under the symbol could be positive or negative. Remember, we did some examples where we took the cube root of negative 8 and we said it's negative 2. And of course, the cube root of 64 we said was equal to 4. So really the domain right away you could say is negative infinity to positive infinity. Really what that's saying is x could be any number whatsoever. There's no restrictions on x. So when this number out here is an odd number, like a 3 or a 5, the domain is always going to be negative infinity to positive infinity. When the number out here is even, like a 2 or a 4 or 6, take what's underneath the radical symbol and set it to be greater than or equal to 0 to find the domain. All right, let's do a few more. How about graphing a square root function? All right, so on this one, they want me to graph this function. It says plot 4 points, the leftmost point, and then 3 additional points. Then you're going to graph this. All right, well, let's make a table up. Okay. Now, I want to know what is the leftmost point of this graph. Well, to find the leftmost point, I'm going to end up setting this underneath to be 0. Because I know the square root of 0 is 0. So what I'm going to do here to get started is I'm going to take what's underneath and set it equal to 0. When I do that, I'm noticing that x equal -1 will make the y value here equal to 0. So let's work it out. What is f of -1? Well, that's going to be the square root of -1 plus 1. Well, that's the square root of 0. That's just 0. So let's make up a little table like they're showing here. Here's a table to come up with. And in our table, I'm going to add one more point for x, because we said if we let x be -1, then the value of y, in our example, y is the square root of x plus 1. We ended up with y equals 0. So this is going to be the point -1, 0 when we plot it in xy format. All right, well, let me keep going now. What I'd like to do is pick a few other numbers so that when I take the square root, I end up with a perfect square underneath. So when I work this out, what I'd like to work out is things like the square root of 1, the square root of 4, and the square root of 9. Because those are easy square roots to figure out because they give me whole number answers. Well, let me think about this for a second. If I want the quantity underneath to be a 1, what should x equal? I'm going to pick x to be 0, because then this will be the square root of 0 plus 1, which is the square root of 1, which is just 1. So this is going to be 0, 1. All right, what should I pick x to be if I want this number underneath to be a 4? Well, if I pick x to be a 3, 3 plus 1 will be 4. So I'm going to make x equal 3. Then the corresponding y value is 2, and I'll be plotting 3, 2. One last point, I want the quantity underneath to be a 9. Well, if I want the quantity underneath to be a 9, I should make that x equal an 8. So I have this table created. Now we can go graph. Once we have that table, here is the point -1, 0. Here's the point 0, 1. Here's the point 3, 2. And here's the point 8, 3. And you would be graphing this using the Alex graphing tool. All right, let's do a couple more. Let me come up here. It says using absolute values to simplify higher radical expressions. All right, so you'll notice in this case, for these examples in this topic, we're taking the 7th root of a quantity underneath that's being raised to the 7th. That's part A. Part B is we're taking the 8th root of a quantity underneath that's being raised to the 8. So what's going to happen is when you take the 7th root of something being raised to the 7th, in essence, these cancel out. The same thing here. I'm taking the 8th root of a quantity being raised to the 8th. So those cancel out. So here I'm going to end up with just 9 plus x. And here I'm just going to end up with a w. But now what I got to be careful about is on some of these examples, I have to use an absolute value sign. Okay? So how do I know when to use an absolute value sign? Here's the key. It says when n is even, use the absolute value sign on the answer. But when n is odd, you don't need the absolute value sign. And that makes sense if you think about it, because remember, if you took the cube root of -8, the answer could be -2. But if I took the 4th root of 16, I can't have a negative answer. I got to force the answer to be positive. So by using the absolute value symbol, that's forcing the answer to be positive. So this is the key. Let me come here. It says if n is even, you need the absolute value sign on it. So in part B, we had an 8 here. Well, this 8 was even. So it says when n is even, you need an absolute value bar on the answer. Let me come over here. It says if n is odd, you don't need absolute values. So in part A, we had a 7, which is odd. So I don't need absolute value bars. So 9 plus x is the answer for this one. Okay, so notice down here on the answers, 9 plus x, I didn't use absolute values, but on the W, I did. And the key is this box right here. If the root is an even integer, you need absolute values. If n is an odd integer, you don't need it. All right, let me do one more example here. Let me go to one more here. It says using absolute values to simplify square roots. All right, so in this case, they're asking me to work out the square root. Now, you know, whenever there's no root shown out here in front, notice there's no root there. So when I write the square root of y to the 4, there's no root. This means square root. Really, I could put a 2 out in front. That would be okay. But usually we leave this off. We don't put it. We could, but we usually don't put a 2 out in front. But that's really what square root means. There's a 2 out in front. All right, well, when I think about the square root of y to the 4th, I can think of y to the 4th as y to the 2 raised to the 2. So this square root cancels out this 2, and I'm getting the answer y to the 2. Let me come to example B. This is the square root of x to the 22. I'm going to rewrite this as x to the 11 raised to the 2. So I'm intentionally trying to write the quantity underneath the symbol as a quantity to the exponent 2, because then I could think of the square root as canceling out the 2. And that's going to leave me x to the 11. But I have to go back and think to myself, I might need to use absolute value bars here, because I know what's underneath has to be a positive value. Right? Remember, I'm taking square roots here. I can't take the square root of a negative number. Well, for y squared, this is never going to be negative, right? Any quantity that you raise to the exponent 2 is always positive. So I don't have to worry about putting absolute value bars around the y to the 2. I know it's always going to be a positive quantity, so I'm not going to get into any trouble about taking the square root of a negative number. But x to the 11 could end up being negative. You know, if you raise something to an odd exponent, you could get a negative answer. So for x to the 11, I have to put absolute value bars to be on the safe side and make sure I don't end up taking the square root of a negative number. Let me go down here to the explanation. And Notice they said y squared is always non-negative, so there's no need to put absolute value bars here. But x to the 11, I do have to put absolute value bars because x to the 11 could end up being a negative number. Okay? So, to summarize this one, if you're taking the square root of a quantity and you end up with something squared like y squared, you don't need absolute value bars. But when taking a square root, if you end up with an odd exponent like x to the 11, you do need absolute value bars. Okay, so this exponent is odd, this exponent is even. So you have to keep this in mind when absolute value bars are needed. All right, well, hope this is helpful as you're working in Objective 11. And please let me know if you have any questions.